Hello my dear students. Today we are going to discuss the 5 mark section. That is a similar type problem last class we have studied. That is solving the system of linear equation using matrix method. That is, I will tell step by step process you have to do in this problem. So it will be easy to memorize. That is, first step what we need to know. Here we have a system of linear equations. We have to arrange this in the form of Ax equal to B. That is the first step. That is, this can be written as Ax equal to B, where A is the matrix where we have to write the coefficients of x, y and z. Correct. So we can write it as 1, 1, 1, the first coefficients of x, y and z. So the first row become 1, 1, 1. Then the second row become 1, minus 2, 3. 1, minus 2, 3. Third row become 1, minus 1, 1. 1, minus 1, 1. This is A. X means what all variables present, that is x, y, z are the variables present. And B means the values here after equal to sign, 6, 6, 2. That are B. 6, 6, 2. First step we have completed. That is, we have to express this system of linear equations as Ax equal to B. Clear? Next we need to find the determinant of this given matrix, determinant A. And after finding the determinant A, if it is not equal to 0, then we can tell it as a non-singular matrix. If it is non-singular, then what? A inverse exists. So this is the second step. We need to find what? A, determinant A, and we have to check whether it is not equal to 0. So first step finished, we can move to the second step. So students, we are going to find out the determinant A, which is the second step. That is, as usual, just expand along row wise. That is, along row wise we are going to expand. So 1 into first element, just hide its corresponding row and column. You will get it's minus 2, minus minus it will become plus 3. Correct? Then next alternatively the sign will change. Then check its corresponding row and column. Here 1 into 1 it's 1, minus it's 1 into 3. Next last we have plus 1. Its corresponding and row and column just add. Then remaining minus 1. Minus minus we have plus 2. So here what remaining? 3 minus 2 it's 1. Minus here 1 minus 3 we have minus 2. There is a 1 outside. Then plus we have here 2 minus 1 remaining 1. So here 1 is the minus minus we have plus 2. Here we have plus 1. So 2 plus 2 we have 4. 4 is the value of the determinant A, which is not equal to 0. That means it is a non-singular matrix. That means A inverse exists. So that you can write as step 2. Step 2 is what? We have got determinant A is equal to 4, which is not equal to 0, means it is a non-singular matrix. Non-singular matrix means A inverse exists. Last class we have discussed about this. So this is a step 2 we have completed. Just to find out the determinant A. Then third step we have to find out A inverse using the formula 1 by determinant A into adjoint A. So students, we are going to move to step 3. That is, we have to find A inverse using the formula A inverse equal to 1 by determinant A into we have adjoint A. That is, determinant A we already got it as 4. Then what is adjoint A? That is just the cofactors we will find out. Then take the transpose of cofactors. That is called the adjoint A. So for this determinant we are going to find cofactors. That is, what was the determinant? Determinant A was the first row elements 1, 1, 1. Second row it was 1, minus 2, 3. Third row was 1, minus 1, 1. For this each element we are going to find out the cofactors. That is A11 is a cofactor of first element. So just hide its corresponding row and column and take this determinant, that is -2, 3, then -1, 1. Clear? Here we have 1 plus 1. If we add, we are getting a 2. That is an even number. So for even number, just put plus. Okay. Then simplify this as, it's become -2, minus minus, we have plus 3. That is, we have -1. Sorry, it's 1. 3 minus 2, it's 1. Correct. That is the value of A11. This is called the cofactor. So like this we need to find for each element. For example, for A12. Here we have 1 plus 2. We are getting 3, which is an odd number. So we'll put a negative sign. Then just hide its corresponding row and column. Then you will get the determinant 1, 3, 1, 1. So minus sign you have to put outside. 1 into 1, 1. Then 3 into 1, -3. That is, you have minus of -2, that is 2. So just find out for each element cofactors. Okay. So students, we have got the cofactors of the determinant A. These are the elements, that is A11, A12, A13. Similarly, up to A33 we have find out the cofactors of A. So you can write it as cofactors of A as a matrix. That is 1, 1, 1, 2, 1, 3 as first row elements. 1, 2, 1. That is 1, 2, 1. Second row elements we have -2, 0, 2. -2, 0, 2. Third row elements 5, 2, -3. Then taking the transpose of this matrix, we will get adjoint of A, correct? That is, here we are going to take the transpose of this cofactors and we will get adjoint A. Adjoint A is equal to, that is, this row will become first column 1, 2, 1. Second row become second column -2, 0, 2. Then third row become third column -3. So this is called adjoint of A. So we got determinant A here as 4, adjoint A as this matrix. Just to substitute here, you will get A inverse, correct? So students, we have got now A inverse. That is 1 by determinant A is 4, and taking the transpose of cofactors, we got the adjoint A. Now, what is a step 4? We have to write, we already in the first step written like this, now Ax equal to B. From that, if A inverse exists means we can write it as X equal to A inverse B. That is, now we got A inverse, which is this. Just to substitute here, X is what? X, Y, Z. What are the variables? X, Y, Z is the A inverse is now 1 by 4 into we have this matrix. Okay, -2, 5. Then we have 2, 0, -2. Then we have 1, 2, -3. B is what? The 6, 6, 2. 6, 6, 2. So in this, what we have to do, just to multiply these two matrices and simplify. That was the last and final step. Then we can solve for this X, Y and Z. Clear? So how 1 by 4 is already there. Multiply these two matrices. First row and this column. That is 1 into 6, we have 6. Then -12. Then last it's plus 10, correct? What about second row? 2 into 6, it's 12. Plus we have 0 into 6 is 0. Minus we have -4. 2 into 2, 4. Last row, 1 into 6 we have 6. Then plus it's 12. 2 into 6. Last we have -6. Correct? Then just add. Okay. 1 by 4 into we have now 10 plus 6, 16 minus 12 we have 4. Then 12 minus 4 we have 8. Then 6 and 6 will go. Remaining we have 12. On dividing each element with 4. 4 by 4 we have what? 1, 8 by 4 we have 2, 12 by 4 we have 3. So we got the final matrix as 1, 2, 3, which is, this is LHS, this is RHS, that is LHS equating the RHS, that is X, Y, Z is now equal to the matrix 1, 2, 3. That means we have got the solutions of X as 1, Y as 2, then Z as 3. Clear students, this is a solution for this linear set of equations. Clear, I think. Just to follow first step as this Ax equal to B. Second step, find out the determinant A. If it is not equal to 0, it is a non-singular matrix. That means A inverse exists. Then in the third step, we have to find out A inverse as 1 by determinant A into adjoint A. Adjoint A is nothing but transpose of cofactors. While finding cofactors, be patient, okay? And the last step, just a substitute here, X equal to A inverse B. Multiply these two matrices and simplify for X, Y and Z. Okay, keep practicing students. See you soon.